So we'll discuss the key technical concepts associated with data analytics, and the definitions ensure that we have a common vocabulary for the workshop and indeed for life beyond that. And that vocabulary will help your organization in its adoption of data analytics. Here's the outline. We'll start by talking a little bit about big data, a much overused and abused term, but it's a prerequisite to effective data analytics. Then we'll talk a little bit about data analytics maturity, kind of the steps that organizations go through, and we'll describe this, that will help you describe the current state of data analytics adoption at your organization, and that'll help you to decide what you want to do next to achieve more value from your investment in data analytics. For example, should you implement an improved data visualization tool? Should you improve the integration of specific data sources? Should you improve data quality initiatives? And then we'll talk about the data architecture for data analytics. This is a discussion of various ways to store your data so it can be accessed by data analytics software, and we'll wrap this up with a quick discussion of what actually does the path leading to data-driven value consist of. Our learning objectives here are to understand big data, to differentiate key analytics terminology. Muddled use of the data terminology leads to misunderstandings and confusion in many organizations. Misunderstandings of the technology being discussed, confusion about the state of the adoption of data analytics, and I hope I can give you some clear definitions for specific terms. We're going to recognize the data architecture alternatives for data analytics. There are multiple ways to design and build your environment. Be careful about making it too complicated. Be careful about complexity leading to high operating costs and lack of sustainability. And we'll also talk about what the data-driven path to value, what's that concept, and how do you understand it and work your way along it. Okay, starting with big data then, the growth of data analytics occurred as a result of the massive growth of digital data in many organizations. This phenomenon is called big data. It's the trigger that started the huge increase in the adoption of data analytics, especially visual analytics. These two phrases, data analytics and visual analytics, are essential to identifying problems and opportunities in this avalanche of data. Here's how Gartner defines big data as a high volume, high velocity, high variety information assets that demand cost-effective, innovative forms of information processing for enhanced insight and decision-making. As far back as 2001, one of their analysts articulated the now mainstream definitions that we're going to, that I've just used in this definition: volume, velocity, and variety. So some people illustrate it this way. Data volume, many factors contribute to the increase in data volume. Transaction-based data stored through the years increase the amounts of sensor and machine-to-machine data being collected. Data velocity is streaming in at an unprecedented speed and must be dealt with in a timely manner. For example, RFID tags, sensors, smart metering all drive the need to deal with torrents of data in real time. Data variety is about how data comes from all types of sources and all types of formats: structured, numeric data, information created from line of business applications, unstructured text and documents, email, video, audio, stock ticker tape, all of that. So again, this is how the data is growing in terms of volume. And we also see this physically in vast data centers that are growing in size and astonishing, really, how big these places are. So How many of you are struggling to cope with the growing volume of data? Are there any approaches that are helping? For example, more sophisticated managing, archiving, deduplication, use of cloud services, and in some cases, outsourcing data management. Looking at trends in storage costs, the cost per gigabyte continues to plummet. However, people are spending more on storage because the data volume growth is exceeding the price drop. And we're seeing that big data skills are very much in demand when we see billboards like this one. So it becomes a challenge for organizations to attract and retain the people that they want with the skills and experience that they need. So the issues in big data are, first of all, technology, where we have multiple incompatible data silos. And what I mean by incompatible is the format, the structure, and the values are undermining or complexifying data integration. And then we have inadequate software development and management tools. We have people issues such as a shortage of data scientists or lack of communication between the data experts and the business users, and insufficient attention to data quality is often an issue that you'll hear about time and time again. Presumably your organization is wrestling with some of these issues, and what strategies are you pursuing to deal with this? Things to think about. Well, is there value in all of this, or is this just the latest fad? You know, is that how you feel as a surfer being pursued by this giant wave? Do you feel like you're just barely hanging on? Well, there is value in big data. So for example, making it openly available, creating transparency by making big data easily and widely available for business and functional analysis achieves higher quality, lower cost, reduced time to market. Supporting experimental analysis. We have to be able to support innovation and ideas and projects to explore potential concepts. We want to assist in defining market segmentation based on customer organization. We want to support real-time analysis and decision-making. That requires a lot of data from multiple sources. We want to facilitate computer-assisted innovation, which is often the area of simulation. And here's an example, someone's perception of how data analytics can produce productivity increases in sales industry in various industries. So this view here is it's more important in retail than in telecommunications. Now, you know, you can debate these different metrics, but nonetheless, data analytics is important in virtually every industry. And again, we see how the increase in expenditures on related software, hardware, professional services, data management, networking, cloud computing is increasing in response to all of this. Okay, let's talk about data analytics maturity. The value of understanding where your organization likely sits on this maturity model is that it illuminates some ideas for what aspects of data analytics you should consider for attention next. So here is a maturity model that I think makes sense for many organizations. There are other models. This one is taken from the Gartner work. And there are two axes. How much business value is your investment in data analytics generating? And how difficult is it to implement, execute, operate, those kinds of things? So first is, at the bottom left, is descriptive analytics. What happened? Typically in the recent past. Then comes diagnostic analytics. So we're analyzing why did whatever happened happen? And what are the reasons for what happened? Predictive analytics now gets us into forecasting. What will happen? What do I forecast will happen? And prescriptive analytics recommends how can we make it happen? How can I influence what will happen? In my view, organizations can achieve lots of business value even in the earliest stages of the maturity model. In my view, there's no value in trying to push an organization quickly through the stages. Organizations can absorb change only at a finite pace. Trying to speed up only wastes money, creates stress, triggers a backlash. Okay, let's look at these stages in a little more detail. So descriptive analytics, the bottom left, it organizes the data into informational summaries. And of course, in order to create a summary, you have to collect and verify the data. The data is generally only internal data like revenue, sales by product or region, gross margins by product line, and it enables monitoring how different areas of the business are performing. It enables an accurate analysis of the facts on the ground. For example, sales increases or decreases over time, value of outstanding receivables, gross margin by product line, number of defects. And the examples of the business decisions that this can happen is it increases emphasis on collecting accounts receivables, change the manufacturing product mix, increase emphasis on reducing operating expenses. But as you can see on the right there, this is all about looking back in time and trying to learn about what happened in the recent past, and that's as far as this goes. So the diagnostic analytics takes us one step further. It's about analyzing curated data to extract meaningful insights. We're automating these techniques into mechanical processes and algorithms. And they reveal trends in KPIs that are not easily apparent in large volumes of information. For example, percent sales increase or decreases, defect rate, large changes in major expenditures categories. These diagnostics are then reveal these trends, and they're used to drive business decisions. Okay, let me just turn off my video here. There, hopefully that helps. So the example business decisions here, evaluating acquisition and divestitures, improving net income, optimizing processes to increase the overall efficiencies of a manufacturing system. So in this point, we're still looking back in time, but we're bringing together a little more analytical techniques rather than simply presenting the data as we were doing in the previous maturity level. Now, in predictive analytics, the third one, we're encompassing a variety of statistical techniques, including predictive modeling, machine learning, data mining, that analyze current and historical data to make predictions about future or otherwise unknown events. We're exploiting patterns found in the historical and transactional data to identify risks and opportunities. For example, correlations between sales and returns, absenteeism, and quality problems. We're looking at macroeconomic indicators like interest rates, unemployment, confidence surveys. For example, shifts in relative sales of various product lines as predictors of future sales revenue. And the model capture relationship among many variables to allow an assessment of risk or potential that is associated with these conditions. The goal of predictive analytics is to guide decision-making and reduce the risk of making investments that turn out to be unprofitable. Well, here's what happens in predictive analytics. We're looking forward. We're taking the historical data, the current data to create a future forecast. And we're trying to look at earnings, production declines or increases, cash flow forecasts, sales forecasts. Those are all examples. So I want to clarify the relationship among some similar terms that are sometimes used as synonyms when they're not. Predictive analytics always includes a forecast component. Data analytics typically focuses only on historic and current data. Visual analytics focuses on superior presentation of data as charts and may or may not include a forecast component. The confusion occurs because data analytics, which has a precise definition, is frequently used as the umbrella term for all the terms that we're discussing here today. So prescriptive, as you may recall, is the upper right-hand part of the maturity model. It applies mathematical and computational sciences to suggest decision alternatives. Predictive analytics really builds on the results of diagnostic and predictive analytics. For example, we can use it to build scenarios to test the impact of various assumptions that underlie any forecast. How will the consumption of our various products play out into the future? How will new materials such as carbon fiber influence the production of products such as cars, shoes, baby strollers, skis, buildings, whatever you have? Examples of business decisions include recommending preemptive maintenance on production components, recommending changes in financing strategies for future quarters, suggests the disruptive impact of emerging technologies, or suggests the adoption rate of new technologies. So we're in predictive analysis, we're looking at the alternatives and then looking forward in time to see how this might all play out. Okay, let's get a little more technical here in terms of looking at the data architecture. This slide's a little busy, but it suggests that there are really three types of ways to store structured data. The first one is the operational data store. This is the database associated with a system that processes transactions. So it contains the transactional data. It contains very limited recent historical data, and it designs the data structure or the schema to meet the transaction processing requirements, which typically are high performance. It's used by functional staff, meaning some business unit. The data lake, a very common, widely used term in recent years, contains all the data from multiple data source systems without data loss. It contains considerable amounts of historical data. It offers no data integration. It stores all the data in its original schema without conversion of original data values. It maintains a data structure schema from the source systems, and it's often used by data scientists. The data warehouse contains selected data from multiple data sources, contains only selected range of historical data. It integrates the data across data sources. It converts the original data to harmonize values and formats, and it designs a data structure and schema to meet data analysis requirements, and it's often used by data analysts. Now, all three of these types of data stores offer varying amounts of data governance, and they're all based on database technologies of various kinds. So the most integrated of all of these is the data warehouse, and the most segmented or siloed is the operational data store. And all three of these types of data stores have their place in the universe, which is why they exist, and they all offer different challenges to the data analyst. So let's look at how we might bring some of this together. And how does this all start out? So the initial data analytics, how does it really work? What people are doing is that they often start with financial data and they use Excel to perform the analytics, and they're producing charts and tables from that. Now, over time, what tends to happen is you will add additional data stores that you access again from Excel. And as you can see, this is becoming more and more complicated. And because Excel is rather brittle, it doesn't run reliably without lots of hand-holding by an analyst. And occasionally it produces rather embarrassing result. So eventually this approach to data analytics collapses, and it's time for a more sophisticated, robust analytics environment. And that might look, and often before you move to that kind of environment, you may add a certain amount of data visualization that's more sophisticated than Excel. Here's what a data warehouse application context looks like. So you have the same data sources or even more than you did in the Excel environment. And then you add a data warehouse that brings this all together. So the problem here is this approach requires sometimes horrendously complex software. And the advantages are you're now integrating the data into a single authoritative view, and you're highlighting data quality issues for resolution. You're simplifying every query that needs to be developed because the data appears flatter and well integrated, and it performs queries quite quickly. Now, there are some disadvantages here. It requires a lot of ETL software to bring all of this together. ETL stands for extract, transform, and load. And this environment requires lots of operational work for data copying and transforming the data. And developing and maintaining the data warehouse as it grows to encompass more data sources can become quite expensive over time. So you may say, well, wait a minute, there's no data analytics in this, and you're right. So let's look at the other half of this diagram. We'll start with the data warehouse at the top. And our data analytics environment is often described like this. Where at the top left, you have a query library of everything that you've built up over time. You have configuration data such as color palettes, logos, shared modules. You have summary data that's been updated from the data warehouse for common queries to dramatically improve performance. And often you have a lot of calculated columns there. The advantage of that is not only improved performance, but they enforce a common algorithm for how you calculate calculated columns in your organization. So if the cost of this scares you, what are the alternatives? Well, it turns out that technology can bail you out. Oh, sorry, before we get to that, these are the typical products of your data analytics work: charts, tables, reports, and exports. Now, you may say, well, why do I need exports if I have a comprehensive environment? And the answer is you probably don't. But most people don't have a comprehensive environment. It's only partial coverage, so they do end up needing that. Okay, let's look at the next. So again, we have, sorry. So in this example, what we're showing here, so let me just back up and show what's happened here. This assumes that all of the data that you have available to you must come from the data warehouse. Well, the reality is that over time, you may find yourself in a situation where you want to blend the data warehouse with other operational data stores and avoid the cost of bringing all this data into the data warehouse. This used to be impossible. but the advances of software capability plus the reduction in computing resource costs means that this is now feasible, where you have the data analytics like before, but now can in fact make it look as if the operational data stores are integrated with the data warehouse when they're not. And this is an important diagram because it describes the reality that many organizations face in how their data is available. And this has only been possible in the last few years as the data analytics software has become more sophisticated. So this is probably where many organizations are going to end up in the future in their data analytics environment. So let's switch to the data-driven path to value. It's worth understanding what all the steps are along this path. So we start with the data from operations such as date, location, production volume, or units sold. And we add unit price to produce gross revenue, for example. And then we'll report that from many locations to produce management reports. And we may do some analytics, which is all about understanding the variances that are occurring. And then that helps us to bring decisions to, helps us to support decisions such as ones to emphasize operational excellence or acquisition and divestiture. And that leads to action, where we actually expect someone in operations or marketing or production to do something. And then that produces business value, either in terms of additional revenue, additional margin, or increases in share price. Now you may say, well, I can understand this path. It sounds very straightforward. Why do many organizations struggle with this? Well, the major problem here is that data quality problems can create risks that either create a misleading outcome or any subsequent step along this path. And then there's the problem of Excel that has bugs that are misleading us. So improving our data will help us to make this path better. How does it work in the land of Dilbert? Consultants say 3 quintillion bytes of data are created every day. It comes from everywhere. It knows all. According to the book of Wikipedia, its name is big data. Well, there's a lot of misunderstanding going on here. The description of big data is definitely not found. This description of big data is definitely not found in Wikipedia. So the recommendations are that to use the terminology correctly within your organization, share the data-driven path to value concepts among those that you come in contact with, and don't think that data analytics, you can sell it or accelerate its adoption based on its intrinsic technical merits. Focus on describing and producing tangible business benefits. And those are always about cost reduction of revenue increases. And if you want to understand more about when to use a data warehouse and when to avoid it, you can read my article on this subject that's in the downloads. And maybe it'll give you an idea of how best to deliver value and avoid excessive cost. So let's look at this a little bit, reflect upon what we've just discussed. How much data, how much value does big data produce? And the answer is none by itself. However, with data analytics, big data can produce a lot of business value. What differentiates predictive analytics from diagnostic analytics? Predictive analytics tries to predict the future, typically using historical trends. Diagnostic analytics looks back and tries to answer these questions. Why did it happen? What were the reasons for what happened? And predictive analytics guides decision-making and reduces the risk of making investments that turn out to be unprofitable. What are the benefits as organizations move to a more data-driven approach to decision-making? A more data-driven approach reduces risk of decisions that destroy shareholder value and increases the probability of sound decisions that increase shareholder value. What are the impediments as organizations try to move toward a more data-driven approach? Some simply view the current approach, whatever they're doing, as sufficient, and that's probably not true. Sometimes they distrust the underlying data, and there's probably reason for that, but that shouldn't keep them from trying to make that data better. They're unsure that the predictions are accurate enough to be defensible. There's no question that happens, but you can improve your environment. And sometimes it's just the issue of the loss of personal standing or prestige for the expert on the topic. And you just as soon not deal with that. But predictive analytics is even invading the world of the fortune teller. Why change? Well, I could see where the future was taking me. Just as Madame Zaza has repositioned her career and introduced new technology in her work, predictive analytics is opening up new and interesting opportunities for data management specialists, business analysts, and data scientists.